8th grade, happy Wednesday. Yesterday we learned about what is a chemical formula and what it can tell us. Today we're going to learn how to read them and then how to balance them due to the law of conservation of mass. So let's get started. We learned yesterday that a chemical formula has two parts, our reactants and our products. And our arrow is showing us that a chemical reaction is happening. So our reactants react together to form the products. So let's have an example of everybody's favorite molecule, water. So we know that water starts with H2 plus O yields H2O. You should know that H and O are your reactants and H2O are your products. But what does this actually mean? What do all of these numbers and these letters and these plus signs mean? Well, every time you see a letter or a group of letters together with a with a subscript at the bottom, that's telling you how many of that element there are. So in this case, this is telling us that we have two hydrogen atoms that are ready to react. H2, that subscript says 2 is hydrogen, two hydrogens. Now that plus sign is telling us another ingredient that's coming in. So these aren't bonded together yet. That plus sign tells us that they are separate. They are not together. So this doesn't have any subscript. That means we're just going to assume it's 1. In chemical formulas, if there's no number there, we're going to assume that it's the number 1. So we only have one oxygen atom as our reactants. Remember, our little arrow shows us that there is a chemical reaction happening, or a chemical change happening, right? Yields H2O. Now you'll notice I still have these same elements are involved, right? Our hydrogen and our oxygen, those didn't change, but how they are formed together and the bonds that are between them, that's what changed. There's no plus sign anymore between the H and the O. That means that everything in this little group that are together with no spaces is chemically bonded together. So this whole thing is one molecule put all together. So, but the subscripts still mean the same thing. But instead of being apart, I have two hydrogen and one oxygen bonded together. So that's showing me that I have my oxygen and I have my hydrogen. This is my molecule because they are bonded together because there's no space. Another way that you can write chemical formulas is sometimes they have what is called a coefficient in front of them, which means that I could have 2H2 plus O yields 2H2O. We're going to talk about this. This isn't balanced, but I'm just doing it as an example. So when you add that coefficient, or you're doubling everything that goes behind it. So if I have two H2s, this is basically telling me that I have two of these little guys. So two H2s altogether, you would have 4 hydrogens because you have H2, here's one of them, but this number right here is telling you that in this equation, you actually have 2 of them. So that means you have another H2. Everybody see that? Then you aren't bonded because then you have your oxygen right there. Yields, again, your coefficient is here. That's telling you that everything that goes behind it to double it or triple it or quadruple it, depending on what number this is. So this right here is telling you that you have 2 H2Os, which means you have 1 and you have 2. Now, some of you might not need to write it out. You might be able to say, okay, I have 2 H2s, 2 times 2 is 4. If I have 2 molecules, each have 2 hydrogens in them, I know I have 4 hydrogens. If your brain doesn't work like that, that's okay. Make sure you write out your molecules every time. For example, over here, I know that I have 2 H2s. Again, that's 4. But remember, you now have 2 oxygens because this whole molecule is part of this coefficient. So it doubles everything that goes behind it. So that's where those 2 oxygen comes from. Your subscript only deals with whatever element it is next to. Your coefficient, that deals with the whole thing. So that's the difference between subscripts, which are these guys, and coefficients over here. That makes a difference because balancing a chemical equation means that you are making sure that it listens to the law of conservation of mass, which means matter can neither be created nor destroyed. So in our chemical reactions, remember, we're just changing it. We're not creating any matter and we're not destroying it. We're changing those bonds. So that means, according to the law of conservation of mass, your reactants, your number of atoms in your reactants needs to equal your number of atoms in your product. Okay? So, for example, that first one that we had was super easy, right? H2 plus O yields H2O. How you want to go about making sure a chemical reaction is balanced is by writing out everything you have. So I have hydrogens and I have oxygens. I have 2 hydrogens and I have 1 oxygen. Now let's check our other side. Even though it's a molecule, we're counting atoms now. We're not counting molecules. We're counting individual atoms when we are looking to see if it's balanced. So I look here, I have 2 hydrogens and I have 1 oxygen. Now you look, do your reactants and your products, do they line up? Well, okay, I have 2 hydrogens, 1 oxygen, 1 oxygen. This is a good chemical formula because it is balanced. Now, it's not always going to be like that. Sometimes you have to change your coefficient to make your chemical reactions balanced. Let's have an example here. I want to use black. So I have CH4, which is methane, and I want you guys to try to write this out. You can just do it on a scrap piece of paper, or if you have a whiteboard at home, you can use a whiteboard. I like whiteboards because I make a lot of mistakes when it comes to math and chemistry. So I have CH4 plus O2 yields CO2 plus H2O. This is a reaction for when we burn methane. Like a lot of methane is in a lot of furnaces. So this is the reaction that happens when you burn methane in your furnace in the presence of oxygen. It releases CO2 and H2O. Okay? So that's the chemical formula. We have to see, does this chemical formula follow the law of conservation of mass, or do we have to change some coefficients to make it all line up? So let's count. I have let's go my first molecule, CH4. This is telling me that I have 4 hydrogens bonded to 1 carbon. There's no coefficient in front of it, so I'm assuming I just have 1 molecule of it, okay? So in this molecule, I have 1 carbon, and for hydrogen, I have 4 of them. I also have 2 oxygen. And then I have my O's and I have 2. Let's see what's going on the other side and if it matches up. Remember, when you are balancing, you are just counting atoms. So what atoms do you have? Well, they should match up. So we know we're going to have C's, we're going to have H's, and we're going to have O's. I look, okay, there's 1 C there. Nope, no other C's, so just 1. H2, that's showing me that there's 2 of those hydrogen. So I have 2 of them. And my O's, I have 1, 2, 3. I go to look to see what is balanced. I have 2 carbons. Okay, we're balanced. We're good to go. I have 4 hydrogens over here, but I only have 2 over here. So this is not balanced. This is not okay. because where did those two hydrogens go? I can't destroy them. If they were in the reactants, they have to be somewhere else in the products. Now my oxygen, over here I have 2, over here I have 3. Again, not okay. But luckily for us, there's a way that we can change this reaction to make it balanced. We have to add coefficients to the front until we find common multiples for each one. So I know I have to double the amount of hydrogens that I have over here. I know I can do that by, I'll give myself some more room here, by adding a 2 to my water. Remember, if you add a coefficient, it doubles everything that goes behind it. So now I just made 2 H2O. Remember, guys, when you're balancing chemical formulas, you can only add these coefficients. You can't mess with the molecule. You can't mess with that subscript. You can only add molecules. So if I have 2 H2Os, let's go through it again. Okay, I have 1 carbon still. I have 2 molecules, 2 hydrogens each. So now I actually have 4 hydrogens. Everybody see that? 2 and then 2. But now this also did something to my oxygens. So I have to recount my oxygens. I have 2 here and 2 there, right? Because I have 2 here because of the O2. Plus, I now have 2 molecules of H2O. That gives me 2 more oxygens. So now I have 4 oxygens. So let's see if it's balanced. Carbon and carbon, good. Hydrogen 4, perfect. Well, now my oxygens aren't balanced. I have 2 over here and I have 4 over here. You want to find the least common multiple between these two. How can I turn 2 into 4? I can double it. How can I double that? I go right here and I add my coefficient. That says I have 2 molecules of O2, which 2 times 2, I now have 4. It didn't change anything here. It didn't change anything here. It just made 2 of that O2 molecule. So let's check to see if I'm balanced. Carbon and carbon, hydrogen and hydrogen, 4 and 4, oxygen and oxygen, 4 and 4. I now have a balanced equation that follows the law of conservation of mass. If you have the number of atoms in here, needs to match up to the number of atoms in here. All right, guys, you guys are going to practice this today using a gizmo. If you're still lost, the beauty of having a Screencastify is you can always watch it again. But let's see what's expected of you. So your assignment today is this Google Doc that has to do with balancing chemical equations. Make sure you go up to File, make a copy, so that way you have your own copy. And you're just basically going to go to explorelearning.com and you're going to launch the Balancing Chemical Equations gizmo. Everything that you need to know to follow this gizmo is right here. You guys have to read. I know it's so hard for 8th graders to follow directions, but you guys do have to read. Everything that you need is here. You're going to go through, answer the questions. Everywhere there's a box, usually you'll have to type in a number, okay? I want you to do the warm-up, and I want you to do activity A. Then at the end, number 3, it says practice. Balance the following chemical equations. These equations are not in the gizmo. This is practice. So here, you're going to be putting in coefficients. You're going to do your own version of this for those. If you have any questions, you guys can email me. My office hours are 11 to noon today. You'll find the Zoom on my Canvas page, so you can just hop on that Zoom link if you have any questions. On Thursday, we're going to practice balancing chemical equations a little bit more, so don't get overwhelmed. This is hard for you guys, okay? We'll spend plenty of time practicing it. All right, guys, have a good Wednesday, and I will see you Thursday.